Before I launch into the project, so I'd like to acknowledge our collaborators from the VDL team. So in particular, Stephanie Rossoff, Jerry Torreson, Mary Thurn, Paolo Fiorante, Albert Rovira, Mats Sturres, and we held a stakeholder workshop in June 2018, and thanks for those who participated. When we started the project early in the year, we looked at the VDL data, and we quickly realized that it won't be an easy task. So the lab data we have available is highly complex and highly diverse. And we've got a data set that reaches back to 2001. So there are over 500 procedures, and to make things even more complicated, there are different access and permissions to the cases we've got at the VDL. So, and to make things even more complex, certain producers have agreements in place to share the data. So there's also some cross-linkage there. So an overall a challenging environment from a data point of view. When we look at the VDL, there are certain goals. So it's protecting animal and human health through early detection and monitoring of animal disease, providing information for action. And so the system should provide easy access to the cases, to the procedure, and to the test results for VDL customers. So the solution we are currently working on is extending what is currently available with the VDL laboratory information management system. And so we are looking at the system where we like to combine results to generate insights into population level trends. We want to have better ways to interrogate data, and with lab data, it became very obvious it's spatial information, so spatial visualization is very important because we know the farm locations and where the case is happening, so we are looking at some ways to represent that. So for the project, so it's the better access to the cases, but we also put add-ons on top of it. So that's for now, so for that project phase to March next year. So we're planning an add-on with genetic analysis and also susceptibility testing. We had a phase at the start for, I think it was roughly 4 or 5 months, where we just were working on the interface and how the system could work and how people would access it. And so it became obvious it needed to be easy to be used. And so we had different audiences, and the key really is to provide information at the right time. So ideally, we don't want to be more than 3 clicks away from the information we want to provide. With the user interface, we tried to go a little bit left field and look not just in what's available in the veterinary space. So we discovered actually that travel sites are somehow close to where we wanted to head. So top right, you see the booking.com site. And so probably quite some people in this room have already used that one. So when I traveled to Minneapolis, put in a location, you put in your dates, and then in booking.com, you get that button with show map. So you can click on it, and that's that view there. So you get then more extended filters. You can select if you want to have free Wi-Fi, if you need parking, and so on. So you can filter further down. And at the same time, you have the list there with
Don't move.
All right.
Okay.
Better. with the list there with hotels, and we instantly see where it's located because location is important. So we quite liked how that is split up with a breakdown of the places and the map view. You can click on the map, you can click on the list. Another site we looked at, so the left one is Airbnb. And so we quite liked how the filter works there because you can build up the filter, for instance, the date where you want to travel, and it puts it directly on the button. So you can add the next filter, how many of you are traveling. So it builds up the filters, and we quite like that one. I'd like to show you a little bit around how it works. So currently it's a prototype version, and we are developing it. And I've got some screen casts there, which should give you a bit of an impression how the system going to work. Okay, so that's the user interface. So it's some similarity to Booking.com. So we've got to the left a list with cases. So for instance, a veterinarian or a producer can log in, and then they see their cases. And to the right, we have the map view. And with the map view, so we applied a clustering. So when you see that round circle there with 60 on it, so that means there's 60 cases associated to it. And you can zoom in and break up the cluster. I'd like to show you how the filtering works. So just get that going, and so I can put in the time frame I'm looking at, so it then filters down the cases. So in that example, I go to, for instance, the 1st August of 2018. So I select that, it instantly updates the list, and it updates the cases on the map. So I can choose the location, so I can drill into the either state or county, and so I can deselect or select. Then procedures, so that for that demo I just look at PCR, EU and NA. So later on it will be more procedures. And then you can drill into more detailed filters. So as an example, I can just look at certain farms. And so we scrambled up the data there, so and then anonymized the farms there. So that's why you just see the farm 11, 13, 16, and so on. So you can select the farms, and it instantly updates it to the left and shows the cases on the map. You can also look into filter things like specimens, so if it's a blood swab or oral fluid, or I can filter against the farm type. So a whole range of filters that are available. And we also like to code favorite searches for the application. Okay. Next one, I'd like to show how the map interaction works with, and how you can select cases there and drill into certain cases. So that's an example where you click into the map, zoom in, and then you see the cluster breaking up. You can, I think that's coming next. So you can hover over, and then you see the area where the cluster draws in the farms. So where the farms locations are located. When nothing shows up, that means that's just one farm and one location. And you can click into it, so it fans out. And you can then explore the cases. So the further outmost case, so that is the most recent one. So you can drill into. You already get a feedback because we have just selected one procedure. So you get feedback if that was a positive or negative outcome. So you can also filter against positive onlys or negative onlys, and then you see the farm locations, and again can drill into the cases. Okay, so now we carry on. So we added some tools to the map, which helps you. So when you are interested in a specific area, so you can click on the map, and we've got a polygon select tool. So you can sort of ring fence a specific area, and then you close the polygon. And so what it doesn't change that selection here because that's driven by the filter. So it highlights then the cases and the farm locations in the case list. So again, you can click on a case and then further drill into it. So I get PERS, EU, and NA, and you get more detailed information. So whenever you see the 3 round dots, you can drill more into the information. Yeah. Okay. So I'd like to show you a quick overview of the genetics module. So that's currently in development, and that's in the next phase. But I've got some screen mock-ups so that you get a bit of an idea where we are heading. And I'm also keen when we talk later on about what you think or what we can add to it. So always keen to get your feedback. So with the PERS analysis, it also works off the cases you see to the left. So I choose which ones I want to include in my analysis, and I have different outputs available. So for instance, I can plot trees or distance matrix or distance map, different tree styles, and you can also include further data. For instance, the plan is that you can include reference sequences that will be provided with the system. But you can also upload your own sequences and compare it with the data that's already there. So that's an example of the tree. So it highlights selected samples and reference samples. So you can play with the information you've got available. So that's an example of the distance matrix against, again, different ways how to display that one. And that's the distance map. So that's the similarity. So you choose a sequence, and then you see how genetically the genetic distance to the sample you've chosen. So that's that one in a nutshell. And so the other module we are looking at is the susceptibility profiles. I'd like to show you a couple of visualizations around that one. So that's when you select a specific case and a specific tube, and it compares the 2 pathogens. And so that's the antimicrobics that were tested. So the susceptible ones that get highlighted in green in that example. So you can also drill further in it and then choose a specific organism and then get the breakpoint information. We also are planning to provide cumulative visualizations and outputs. So that's examples of when you choose a pathogen or up to 4 antimicrobials, and you see how the susceptibility profile evolves over the years. So again, that is just mock data for now, but that data we feed in will be based on VDL data. So that's the last one. So that again drills further in it, and that's the rolling the susceptibility always over the last 12 months. So it always pulls in the latest data. Quick overview of the technology we are using. So with the novel approaches, or the programming of the app is done, the majority is done in R, and we use an R package on top of it, which helps us with output to the web. So all the application is browser-based, and you will be able to access it over the internet. And so we extend it as required, and so it can then enable that reactive programming, so that you change a value and that instantly updates, for instance, the case list in the map, and that's really built for that one. So we are planning it for the ability to scale, and so we set up a dedicated server at UMN currently. Quick overview. So we've got a VDL system to the left, and to the right is Lab SAVI, so the system we're building up, and we run an automated data import every night, and so that goes into a database. We use a product that's called RStudio Connect, so that helps us with performance tuning, and so that also acts as a web server. And then it outputs a web interface where then VDL clients, veterinarians, or researchers can access it. Should be accessible on different devices, so that can be the mobile phone or tablet, laptop, or desktop computer. Outlook is we are currently that's under active development, and we're planning prototype testing a bit later in the year with early adopters. And so the fully functional version, so with genetics and the susceptibility testing, is planned for towards mid-2019. And going beyond that, we want to include more procedures, and potentially also include other species, so for instance poultry, and also extend the analytical capability into, for instance, risk maps or advanced quantitative epidemiology EP models. We actively work with stakeholders to make sure the system is fit for purpose and easy to use.